Okay, so I'm going to record the review for Unit 7, where we talked about periodicity of the periodic table and VSEPR theory and electron dot structure and just all kinds of things. So let's look at what I have for you. Okay, what I did was I just went through and answered all the questions. So I'm going to leave this here for a little while and let you look at it. And then I'm going to continue. You're going to pause and keep on looking. So there's 1, 2, 3. There's 4, 5, 6, 7, and 8. You can pause whenever you need to and write down whatever you need. Here's the chart. Now, we don't expect your drawings to look like this, but I just kind of stole some images off the internet because I can't draw either. But you do need to know this chart, particularly this column and this column, because you're going to be asked some questions about the shape of the molecule. It's called molecular geometry. So take a little while, pause it, study that. Get it straight in your mind, make sure you know it and how to use it. Okay, here's 10 through 12. $13. You can pause anytime you need. Here's 14 and 15 and 16 and 17. I'm going to have to draw on 18. So pause and copy. Okay, 18 asks you to draw the electron dot structures. And we want to draw electron dot structures, but we want to make sure that we're only including the valence electrons. Only the valence electrons. And we've done a whole bunch of these in class, so it shouldn't be any big surprise for you. If you look at chlorine on the periodic table, chlorine has 7 electrons, but it's a Cl minus, meaning it's an ion. It's actually called an anion because it has negative charge. So I'm going to give the dot structure, and that's not what I really should be doing. Let's be completely accurate. Here's my S electrons. Here's the first P, second and third, and then I go back and fill up the P. So that's really what it should look like. And then it needs a bracket to show that it's an ion, and we need to see those brackets, and then we need to see the sign of the charge, how big the charge is. So we will know that you understand what an ion is. I have hydrogen. Kind of skipped that one. It has 1 electron. And then I had neon. Neon has 8 valence electrons because it's in group 8A. It's a noble gas, so it's completely full. All right. The next one is, I've already done the chloride ion, aluminum. Aluminum is in group 3A, so it has 3 valence electrons, and that's what it needs to look like. If you draw it like this, in my class, I will mark that wrong. The first 2 need to be in a pair because that's the S orbitals that are completely filled, and then I start filling the P's, just like Hund's rule tells me. All right, aluminum, calcium. Calcium has 2 valence electrons. It's in group 2A. There they are. Oxygen. Oxygen has 6, so there's the first 2, 3, 4, 5, and here's the 6th one. O2. O2 is going to have a total of 2 oxygens, each with 6 electrons. So it has a total of 12 electrons that I need to show. So I'm going to do this and this, because there's my 2 oxygens. There's 2, 4, 6, 8, 10, 12. Now, I know that because I've done this a long time. You just have to practice. Get your pencil out, try it. If it doesn't work, erase it. Try it again until you get the right number of valence electrons. All right, after oxygen, we have NH4+. So NH4, nitrogen has 5 valence electrons. And then I have 4 hydrogens, each with 1. And then it says it has a +1 charge, so I'm going to lose one of those electrons. So instead of 9, I have 8 now. So NH4 is going to look like a nitrogen with 4 hydrogens around it. There's 8. That's what I needed. There's 2 for each hydrogen. I'm going to put a bracket around it and put a plus sign. So there's my NH4 plus ion. Now I want to talk about hydrogen a little bit because I had some students that were very curious as to why hydrogen could only have 2 electrons. It doesn't follow the octet rule. Well, if you look at where oxygen is on the periodic table, it's the very first element. That means it's got energy level 1. The maximum amount of electrons that energy level 1 can handle is 2. So hydrogen can never have more than 2. It's that simple. Don't make it real hard on yourself. So my NH4 plus is going to look like that. Make sure you give me a bracket and the charge out there. HCN, okay, so HCN, hydrogen has 1 electron, carbon has 4, nitrogen has 5. So that gives me 10 electrons, so I need a H, a C, and an N. So again, I'm just going to play. So if I needed 10 electrons, I'm going to count. 2, 4, 6, 8, 10. Whoa, I have way too many. So I'm going to get rid of this one. And instead of drawing it there, I'm going to put those 2 electrons there. So that gives me 2, 4, 6, 8, 10, 12, 14. Still too many. So I'm going to put one there. So there's 8 here. And there are way too many around my carbon. So this is not looking real good for me. So I'm going to erase it and try it again. Again, all I do is play, and when I can't get it, erase it, try again until I get it. Okay, so I went off and practiced to figure it out so I don't erase it 95 times here and lose you. So here's my H, here's my carbon, here's my nitrogen. So I have 2 around my hydrogen, 8 around my carbon, 8 around my nitrogen. I'm going to count 2, 4, 6, 8, 10. So that one's done correctly. Finally. And then my next one is NF3. So let me erase some of these. All right, NF3. Nitrogen has 5 electrons. I have 3 fluorines, each of them with 7. So that's 26 electrons. So I'm going to put my nitrogen in the middle. Be as symmetrical as possible. There's 8, 10, 12, 14, 16, 18, 20, 22, 24, and there's my 25th and 26th. Now I'm going to check the octet rule. 8 here, 8 here, 8 here, 8 here. I'm going to count again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So that's NF3. And then I want to look at the very last one, which is CFCl3. So I have 4 here, 7 for fluorine, and 21 for chlorine. The reason I have 21 is I have 7 electrons on each chlorine, and I have 3 of them. So that's 21 and 7 is 28, and 4 more is 32. Put carbon in the middle, give me a chlorine here, a chlorine here, and a chlorine here. So I go back and dot, fill in my electron dot structures for everybody, and you have to put these dots in. If you just give me that without dots, I mark it wrong and move on with my life. So give me your dots. Please, I need to know that you understand what this concept is all about. All right, so there's 8, 16, 24, 32, 8 around my carbon, 8 around everybody else. So that looks really good. All right, now question 19 says, now do those same things, but I want you to talk about the shape of them. All right? And so that goes back to that chart. If you go back up here, let's go up here. Okay, so to be able to answer question 19, you need this chart. So pull it out and keep it near you so you can see what's going on. I'm going to go on and show you how to work them. They're not terribly difficult, especially if you understand that chart. So first one on question 19, it is a, let's see, O2. So you look again at that electron dot structure we just did on 18, and you know that oxygen has 6 valence electrons, and there are 2 of them. So I need to show 12 electrons. So I have O, 2, 4, 6, 8, 10, 12. These oxygens want to get as far apart as possible, so the only way they can align themselves is to be linear, which is 180 degrees apart. So there's the first one. NH3, nitrogen has 5 electrons. There are 3 hydrogens, so that's 8. So I put an N in the middle, come around and put a hydrogen. So I have 2, 4, 6, 8. 8 around my nitrogen. Each hydrogen has 2. This is going to push these hydrogens as far away as possible. So I have 3 bonding pairs of electrons. And then I have that 1 lone pair. And when I look at that on my chart, that tells me that the shape has to be trigonal pyramidal. Trigonal, P-Y-R-A-M-I-D-A-L, pyramidal. And the angles are 109.5 degrees. All right, let's move on to the next one. The next one is BF3. So boron has 5 electrons, and then fluorine has 3 fluorines, each with 7. So that's 21 plus 5 is 26 electrons. So fluorine is one of the ones that does not follow the octet rule. We put that in your notes, PBS. Phosphorus, boron, and sulfur do not have to follow the octet rule when they are bonded with a halogen. So it's okay if there's only 6 around boron. There's no lone pair. I have 3 regions of electron density, so this one's going to be trigonal planar. All right. Then my H2SE. H2SE. Selenium is Se, and it has 6 electrons. And then I have 2 hydrogens, each of them with 1 electron, for a total of 8. So I have Se in the middle, an H here, an H here. So I have 2 lone pairs and 2 bonds. So that tells me that it is a bent molecule, and my angle is 109.5. And then I have, okay, my last one is CFCl3. So I have 4 electrons plus 7 electrons plus 3 fluorines, each with 7 electrons. So that's 21 and 11 is 32. So I have carbon in the middle, fluorine, chlorine, chlorine, chlorine. Go around and put my electrons, and I'm going to run out of time, so I'm going to go quick. I have 4 regions around, and I'm always looking at my central atom, so I have 4 regions of electron density, so that one is tetrahedral. Okay, so tetrahedral should be 109.5. Now, I think I might have said the wrong angle for trigonal planar. So go back and fix it if I did, because I should have told you that it was 120 degrees. And I'm not sure. I think I probably said 109.5, so we can make that change. All right, so then we need to scroll on down and let you see the rest of this. So let's see if technology is going to cooperate. So there's number 20. Pause when you're ready. There's 21 through 22. Pause when you're ready. 23, 24, and 25. Here's 26 through 29. Pause. Here's 30 through 33. Pause. Here's 34 through 37. And then here is 38. And the chart is given to you.